So section 3.2, we're going to cover a little bit of bonus material here. Basically what we're going to start out with is trying to make sure we recognize the end behavior of some polynomials. So to that end, you had a handout that looked like this. Our end behavior is broken up into 4 different things. 2 of them are when you have an odd degree polynomial, and the other 2 are when you have an even degree polynomial. And then the other stratum in this whole affair is whether or not you have a positive leading coefficient or a negative leading coefficient. So your odd degree polynomials have behavior that has these ends pointing in opposite direction. Whereas if you have an even degree polynomial, then you have ends pointing in the same direction. So those are the 2 basic types of behavior you're going to have there. And with that in mind, let's take a look at our first example, which is this one. X cubed plus or minus 13x squared plus 21x minus 7. So you want to classify this into one of the 4 types of behavior here. So we'll call them 1, 2, 3, and 4, left to right. Which one do you think this is going to fall into? 1, 2, 3, or 4?
1.
Yeah, the first one. So the first one because it has an odd degree and a positive leading coefficient. That means as x approaches infinity, y approaches infinity. It's going to go up and to the right. And then on the other hand, as x approaches infinity, y approaches negative infinity. It's going to go down and to the left. So tough to say what happens in between, but eventually, somewhere here, it's going to go down to the left and up to the right. So up towards positive infinity, out the x-axis, down towards negative infinity, out the negative x-axis. Cool. Let's do the same thing for this one. Let's classify that one. So negative 5 times x to the 4th plus 7x plus 9. Now, of course, the operative thing to notice here is that this is an even degree and has a negative leading coefficient. So that tells us a couple things right away about its behavior. Which of our 4 does this one fall into?
Number 4.
Yeah, the 4th one right here. So eventually this is going to go down on both ends. So that means as x approaches infinity, this is going to approach negative infinity. As this approaches infinity, negative infinity, the y values also approach negative infinity. In fact, there's nothing wrong with double checking yourself on Desmos or on your graphing calculator to kind of look at this. So let's take kind of a quick peek at that one. Bam, looks like that. So not a big surprise. It's kind of matching a little bit of what we expected. If we look at the first one doesn't quite match what we expected. Kind of looks like a parabola facing down. But we know with an odd degree and a positive leading coefficient that eventually it's got to come up to the right. So what that might suggest to you is that you might want to move around with your viewing window a little bit. Maybe zoom out a little bit. Do something like this. And eventually you should figure out that, oh yeah, I didn't have the whole graph. Eventually it has to go up and to the right. So, nice. While we're here working on those limit kind of things, let's take a look at y equals 5 to the x minus 4. So there is a problem like this here, and I think it's here just to remind you of a couple things. So y equals 5 to the x minus 4. And let's just jump back over here. First of all, they're going to ask you what kind of function this is. Is it a polynomial? Is it a logarithmic? Is it an exponential? Is it a rational function? Which of those types of functions is it? Well, in case you've kind of forgotten here, when you have a variable that's part of the exponent, that's an exponential function. So that's the answer to kind of the first part. The second part is as x approaches infinity, what does y do? As x approaches negative infinity, where do your y values go? So let's look at those. So let's back over here. If you ever get lost in D2L, because, or I mean in decimals because you've zoomed around too much, click the home button. It gives you kind of a default view of -10 to 10 on both axes. So as x approaches infinity, if I move out the positive x-axis, so moving to the right, where's the y value going? Y value is going up and up and up towards
Infinity.
positive infinity. Good. So that's the first answer here, is positive infinity. Now the next answer is going to definitely be different than what you've seen with some of these before. As you go out towards negative infinity along the x-axis, what's happening to your y values? They're not going to negative infinity anymore. They're kind of settling down, closer and closer to what number? Take a look at the... Yeah, there you go. Thank you, Dave. Closer and closer to -4. In fact, at some point you get so close that decimals just rounds it and says, all right, we're at -4. So that's your limit, though. That's what's called a horizontal asymptote. Not that we have to worry about that word just now. But there you go, -4. Beautiful, beautiful. Now, I'm of the mind that on the test, which is a week from this Thursday, that I might want to give you problems that are kind of like this stuff. And they're going to give you a polynomial and ask you, you know, which one's which. At least that's what they do on WebAssign. But for myself, I'll probably give you a graph like this, except I won't have any numbers on it. All I have is just the graph and the equation plotted on it as well. So I want you to eliminate some of these and say, all right, well, why can't this first one be the graph? And let's look back at the function and understand a few things about what we would expect from y equals x to the fourth, or y equals -x to the fourth, and finally our actual function. So let's look at this. Y equals x to the fourth. That's roughly going to look like a parabola. So let's see. Draw it like this. So this one's going to face up. It's going to have kind of a squat looking intersection with the x-axis down here, but okay. It's a little flatter than a parabola. A parabola would have a little bit more of a U or V shape somewhere in between there. What's it going to look like if I looked at y equals -x to the fourth? How is that going to change my graph?
It's going to reflect across the x-axis.
Perfect. It's going to flip it down. It's going to reflect across the x-axis. So it's going to look kind of like this. But the problem that you were given was to look and figure out which one of these is the graph of negative of x plus 4 to the fourth power. So let's look back at some of our choices. Could this be it? No. William's shaking his head no. This one was shifted to the right by 4. What do we expect from our graph?
Shift to the left by 4.
Yeah, the plus 4, that horizontal shift is going to go to the left by 4. So, yeah, that first one wouldn't be it. What's wrong with the second one? What did they do to get this graph?
This one up 1.
Well, you got to kind of keep an eye on the scale. The scale is 5 for each of these tick marks.
Oh.
So they shifted this one up by 4 instead of left by 4. Could this be the correct graph? Yeah, that's looking better. That looks like it was shifted to the left by 4, which is what we expected, as opposed to the right by 4 or up by 4. All right, let's do that game again. Play it a couple more times. And there's nothing wrong with you taking out your graphing calculator or taking out decimals and checking, well, which one's which. But you shouldn't need to. You should be able to tell me 2 reasons why this first graph here is not the graph of negative x cubed plus 27. I'll take one of them. What's one reason that this shouldn't be the right graph?
Leading coefficient is negative, so it's not the first line.
Yeah, it has the wrong shape for something that has a leading coefficient, which is negative. Instead of going from left to right and increasing, it should go from left to right and be decreasing. So, okay, so that's one reason. Can anyone else tell me another reason that this is not the right graph?
Shifted down instead of up.
Yeah, shifted down instead of up. So this next one is shifted, or does have the right shape, but it's shifted down. So neither of those is the correct graph. How about the one after that? Which of these 2 is the winner? The left one or the right one?
The left.
Left one's got it all going. It has the proper shape in terms of decreasing, and it's been shifted up by 27. So beautiful. Left one. Now the last one that I want to look at has got a couple things going on in it. Actually, several things. So first of all, you've got this 1/2 out in front. That's going to make a change that's going to be kind of hard to see and appreciate. So for instance, if I looked at the graph of y equals x to the third, and then also looked at the graph of y equals 1/2 x to the third, it's not a real heart-stopping difference. It's like, okay, yeah, I can see that one is shorter than the other one, but it's not going to be a really dramatic difference. So as far as you're concerned, the only thing I'd really take note of is the fact that this leading coefficient is positive. All right? So that means it should have which one of these 2 shapes? The one on the left or the one on the right? Not that these are the right graphs, but should the shape look like this or like this? First one or the second one?
The first one.
First one, yes, thank you. So first one, that's a winner. But the -1 plus 3 should shift it to the right by 1 and up by 3. This one got shifted to the left and then up by 3. So that one's not it. This one can't be it either because it's decreasing as opposed to increasing. You want an increasing function that's been shifted to the right by 1 and up by 3. That's your winner right there. So cool. Cool. All right. So kind of a nice quick review there for us of some of these things. Comments, thoughts, or questions? All right. Cool. You're ready to get started. Good luck on those. Reach out if you have any questions on the homework.